All right, so let's start with the PowerPoint and let's look at what they got for us. Here we go. That PowerPoint, full screen, gas law. So we're going to combine gas law. Now, what they say at the beginning is changes in volume, temperature, pressure, and number of moles can be related using the combined gas law. So we're going to do the same thing we've been doing, but we're just going to use everything. Close your Chromebook. I know you heard me tell you to close your Chromebook the first time. Close it. Thank you. So, combines previous gas laws into one formula. So like I said, that's what we're doing with Boyle's, Gay-Lussac's, Charles' law, and Avogadro's law. We're just smashing them all together to make one big formula. So that formula allows variations in the volume, temperature, pressure, and number of moles to be calculated based on changes in other variables. So something's got to change. I got to have a step 1, and I got to have a step 2 for all the stuff involved in the formula. What this does is shows the relationships exemplified by individual gas laws are maintained even when no variables are held constant. So what they're saying is all of these relationships still work individually even when I'm changing everything. Even when all the pressure and volumes and temperatures and moles change, all of these are still valid and still work. They're just working together like in a more complicated way. So you don't have to worry about what's going up or what's going down this time. There's no direct or inverse relationships. It's just going to be, it depends on how things change. So you just got to plug it in and do the work. So here's your formula. P1 times V1 over N1 times T1 is equal to P2 times V2 over N2 T2. It's written on the board over there. I'm about to write it on the board over here, and we'll do a couple example problems. So let me actually see before we get going how many they do. Usually it's just 2. Oh, is this one just 1? Okay. This one was just 1. So we're gonna make sure that we go through this in detail so everybody gets a good example of what we're doing here. So I'm coming back over here, and we're gonna take a look at our problem and kind of write it up on the board. So the problem says a 0.13 mole sample of ethane gas at a pressure of 0.75 atmospheres and a temperature of 25 degrees Celsius has a volume of 4.2 liters. They give me all that stuff in that first sentence, right? All in one sentence. I get a moles, a pressure, a temperature, and a volume. So this is an N, a P, a T, and a V. All at once, all in one formula, or I mean not formula, but sentence. So I can assume all 4 of those are my number 1. I have an N1, a P1, a T1, and a V1. Then they tell me if the temperature of the gas is decreased to 10 degrees, so my temperature changed, and 0.02 moles of ethane leaks from the balloon, so my moles changed, resulting in a volume of 3.0 liters, so my liters changed, what would the final pressure be? My pressure is also going to change. I need to figure out what it's going to be. So let's write the formula down and let's start to figure some stuff out. So what I know is for a combined gas law, which is literally me just combining the other laws together into one formula, my formula is P1 V1 over N1 T1 is equal to P2 V2 over N2 T2. And now let's start to get my numbers. What I'm going to do, go ahead and block this off. And I'm going to actually write down my formula again, just so I have it. P1 V1 over N1 T1 equals P2 V2 over N2 T2. And obviously, it's a little harder for y'all to erase on your paper, so you don't have to write this down a second time. But you want to just start by plugging your numbers in where you can. That's going to keep you from getting too confused on what's what. So the first thing they give me is moles, right? And it's going to be my first mole, so I know that 0.13 is my N1. So I'm going to go ahead and put that here, 0.13. Or no, is that right? Yeah, 0.13. Now the next thing they give me, my 0.75 atmospheres. Atmospheres is a pressure, so I know that's my P1, 0.75 atmospheres. The next thing they give me is 25 degrees Celsius. That's going to be my T1. But what do I have to do to Celsius temperatures? Yeah, I got to add the 273 because I can't use Celsius. I have to use Kelvin. So 25 plus 273 is 298, right? So 298 is my temperature here. And then they give me my volume, 4.2 liters. That's going to be my first volume, 4.2. So already we're only halfway there, and you can see there's a lot of numbers to keep track of. So you got to use scratch paper. You got to be writing this down. The people who just been looking at the pattern and trying to figure out what I multiply, what I divide, that's fine. I'm not mad at you. That's a quick, efficient way to get through the previous assignments. But you can see here, with all these numbers, you're not going to be able to just figure out what I multiply, what I divide here. You got to write it down. If you don't write it down, you'll never get to the end. Now, let's go to the next sentence. Where are we at? So, if the temperature of the gas is decreased to 10 degrees Celsius, so I know that 10 degrees is my second temperature. I just have to add 273 to it. So my second temperature should be 283. What do they give me next? And 0.02 moles of ethane leaks from the balloon. Here's where they get a little tricky, which they didn't have to because it's already tricky enough, but 0.02 moles leaks. So that means that left the balloon. So I actually need to do a little subtraction. 0.13 minus 0.02 that leaked out is going to be my second moles. So I'm going to have 0.11 moles for my second moles number. 0.11, resulting in a volume of 3.0 liters. So I know this is my second volume, 3.0 liters. I'm multiplying here and there. And then the last thing I need, my pressure too. I don't know that pressure too. They're always going to leave something off. And so I don't know that. That's what I'm trying to solve for. I can leave it as P2, or I can make it an X. And solving for X is something we're a little bit used to. So now, what do we got to do? We're going to do cross multiplying, but first it's probably just easier to multiply everything together. So there's lots of different ways you can do this. If you just want to take it like it is and start to cross multiply it and do all your multiplication division later, you can do that. For me, I like things nice and neat and clean. So I'd probably go ahead and multiply all of these together individually before I cross multiply. So 0.75 times 4.2. Let me do that. 0.75 times 4.2. I get 3.15. So I'm going to put this as 3.15. Well, let me just do another one over here. 0.75 times 4.2. And then I'll just do another one over here. So what did I do? Clear that. What is happening? 0.75 times 4.2 is 3.15 over 0.13 times 298. I got 38.74. 38.74 is equal to X times 3.0. I can't do anything to that yet, but I can multiply 0.11 times 283, and that's going to be 31.13. So now I have this a little bit more simplified. Now I can cross multiply, and it'll be a little easier for me to get done. So when I cross multiply, I multiply these together. 3.15 times 31.13 is equal to these two multiplied together, 38.74 times 3.0 times X. Now I just need to solve for X, so I need to get that by itself. I guess I'll just divide, let me multiply everything together. So 3.15 times 31.13 is 98.059 is equal to 38.74 times 3.0 is 116.22 X. I got to keep the X in there. Now I want to get the X by itself. I divide by 116.22 on both sides. And these are going to cancel out on my right side. Top and bottom cancel out. And what I have is x is equal to 98.059 divided by 116.22. 98.059 divided by 116.22. And I got 0.8437 is equal to x. So let's see if I did that right or completely wrong and what Sapling says about that. But I think we got it right. So they're first just going to organize all their numbers. And if you would like to do this first, write out all the numbers that you have and put a label next to them. That can also help. I just didn't have a lot of room on the board, so I didn't want to use the board up. But they get their moles 1, their pressure 1, their temperature 1, which they need to add 273, their volume 1, and then they go to temperature 2. Moles leaked out, so this is not my moles 2, but how much I subtract to get my moles 2. Volume 2, and we don't know the pressure 2. That's what we're actually looking for. So then, do they have to do conversions? Yes. They have to add 273 to both the temperatures, the 25 and the 10. And they need to subtract the 0.02 moles from the 0.13 moles, and that gets them their moles number 2, which is 0.11 like we had. Then they plug everything in, do all the math, and when you get to the end, 0.84 atmospheres, which is what we got, 0.84 with a little bit of rounding. So, yeah, this is complicated. The other thing I will point out, I'll leave this up while you do this. Let me go to an actual problem in the assignment. So like number 1, an ideal gas has an initial volume of this many liters, a pressure of that, the final temperature of the gas is this, the volume is this, and the pressure is this. They're asking for a temperature. Do they mention moles in here at all? They don't mention moles. And so for these problems, a lot of times, it's not going to be this big. It won't be the full problem where they give you every single number. If they leave something off and you get to the end and you're like, I don't have any moles. I don't have moles 1 or moles 2. Then really what happens, you just take the moles out of the equation. And that's your equation for that problem. If they don't mention moles at all, the moles go away. If they don't mention temperature at all, the temperature goes away. You just assume it's going to stay the same. It won't change any of your math. And so some of these problems will not be as big and long as the one we just did, but they're still going to require a lot of work, and you're going to have to write stuff down. So take your time as you go through it. Use scratch paper. If anybody needs scratch paper, just let me know. I've got scratch paper for you. And obviously, I'm here to help you out. Yes. Yes, for sure. Let me grab some. Yeah, it is a long one. See? We'll get started on this.
Are there any where like the answer is in Kelvin and the problem is
Let's see.
Celsius?
I'm sure at some point they start to fill it in. Let's see. So Kelvin to Kelvin. Kelvin. There's Kelvin. Kelvin. It doesn't look like it so far. There's one temperature they give you in scientific notation, which will look a little bit weird, but you can just put it in your calculator like you normally would. Kelvin. So I don't think so. So far, and I'm on number 11, all the temperatures they're giving you are in Kelvin, so you shouldn't have to do any temperature conversions. Oh, here we go. Well, but those are both in Celsius. But yes, you will have to convert it first. So number 13 and beyond, it looks like they switch over to Celsius, and you'll have to start doing temperature conversion. But before number 13, I don't think you have to do it at all. So yeah. So if you have any questions or want any help, just let me know. And I will help you work through a problem. If you're at home watching this video, I might end it here. If there's a question I want to help someone out with, I might record that also. So If the video keeps going, it'll probably help you out with a problem on your assignment. If you have any questions or need any help, just send me an email and let me know, and I'll get back to you.